Hello.
All right, while we wait to see who joins, why don't you and I try to make a list here of things that have been happening. Just the resources.
Your sorter change, benchmark, allocator benchmark base. Sorting change and your callback, so the offer callback optimization.
Hey, Ian.
Hey, Ian. What else?
What was the callback thing you're talking about? Oh, yeah, I see. Yeah. I guess you could call this.
Yeah.
Okay, I guess we have enough people that we could probably start talking through these. But we were just making a list of trying to capture all the things that have been happening, and we can kind of go over them. There's some stuff here. What else has been happening? Well, I guess I think these are the high-level things we've been doing. So for Ian and so I think Meng and I know most of these things, what's been going on here. For Ian and Chun, do you guys want to talk? Do you guys want us to talk over all these things, or did you have any specific agenda items you wanted to bring up?
So I've skimmed through a bunch of these reviews, and seems like it's gonna help a lot in terms of the master performance. I looked at copy and write. I looked at sorting. I guess that's the random sorting.
No, there's we can talk about those things, but there's some patches that haven't landed yet that
cool.
are up for review now.
I see. So I think I'm bringing this up just because I saw a comment yesterday on one of the JIRAs I'm watching. which was benchmark co-ingestion path on Mesos master.
Mhm.
So I think this was grouped under Schedule API v1 improvements epic. And Greg was asking, is this in the issue? Do we need to do any more benchmarks at this point? So yes, relevant. I know that I personally haven't spent a whole bunch of time investigating on this, but I know that we are certainly, because we're hitting the v1 HTTP API path. So any improvements there can greatly improve things for us.
Okay, and you're mostly interested in the scheduler calls, right?
Yes.
Okay. Yeah, we can talk about that. There hasn't been any work to my no. I guess that's not true. There's been some work just from the fact that we did some moves. We did some copy elimination that would improve the V1 path as well as the original paths, but I don't think there's been any focus yet on the scheduler V1 call ingestion.
Right. So specifically
I think Ilya might have written a benchmark. I seem to remember there being a benchmark a long time ago, and him saying some things about what he found, but I don't remember if we committed that or what. I'd have to go and look through.
Yeah. So there's one committed, and I think the patch I looked at was from Anand, so maybe a different one. Okay, but
was it reconciliation? Do you know?
So the JIRA I'm looking at is 6405, and oh, sorry, it's not committed. It's closed due to inactivity.
Oh, okay.
And that patch was scheduler library. Yeah. Yeah, we can probably talk about this last.
Okay. Anything else you want to cover?
No.
Okay. All right. Let's just walk through these and we can talk about each one. Right now, Mang has some patches that are out that are almost landed for making the resources wrapper do copy on write. That's helpful because a lot of the functionality of the resources wrapper, especially in the allocator, is doing filtering. So say like getting just the unreserved resources out from a resources object. Before the patches, we have to copy them all out, which is rather expensive to do. And often we don't modify the output. And so the approach in this patch is to make the resources wrapper copy on write so that when you do filtering, it's less expensive. I think when Mang, maybe you can correct me, but I think when we ran benchmarks, for the allocator benchmarks, it had a large impact on small clusters, and then it had a pretty small impact on larger clusters, which was why actually some of these other changes are happening. But I think, anything else to add there, Meng, on the performance?
Well, I think those small clusters actually it's not that small.
Okay.
Check. I think around.
Maybe you can maybe we should share the data.
Yeah. The data. Okay, let me try to find it. Preliminary location benchmark. Yeah, yeah, we probably should show the graph. I think you, when we talk about the blog, we will show it anyway. So do you want, yeah, okay, yeah. So I guess you already found it. Yeah, so this is a graph. So comparing the allocator performance across different versions. And the last one on the bottom is copy on write. So uh, yeah, so it's the optimization is more it's more significant when there is less frameworks, and when there are a large number of frameworks. For example, the last column, when it reaches 1K, the sorting overhead becomes dominant. It's less about the filtering, resource copying, and etc. That's why we have been doing some optimization on the sorter as well.
Okay. Anything else to add about the resource copy and write stuff? Or does anyone have any questions about it?
Yeah. So right now it's still like the code is there, but we don't have a good abstraction to like guard the when you want to mutate the underlying resources, you have to like be focused to check that there's only the modifier has the exclusive ownership. So right now it's a little bit brittle, but we have planned to add a better abstraction to force more safe access.
Cool. So I missed. So I was disconnected. But seems like so the more the agents there are, I guess the difference is not that obvious.
I don't know, Meng, if you know whether it's the agents or just the combination of there being more agents and more frameworks, or
oh yeah,
there being more frameworks.
Yeah. So here the ratio is the same. So the agents to frameworks is 10-1. But based on the perf data I got, I think it's mostly about frameworks. Because when you add agents, I don't think it affects the sorting.
Right.
Got it. Yeah.
But I think you have the perf trace. I mean, if people are interested, we can take a look. So basically, it's the sort and the sort function, the sorter, and the calculate shares becomes dominant.
Oops. Yeah, I don't know if people are interested or not, but
yeah, this one, yes.
Oh yeah, so sorting.
So this is the perf profile of the last. So in the graph, you see in the rightmost column when there's I think 1K agents, 10K 10K agents and 1K framework. So this is the perf profile. So you can see the large number of the most time are spent in the allocate function, and within that it's sort. So that's the place where I think the number of frameworks matters.
Yeah, I think with the patches that I have for the sorter that we can talk about, I think if you treat this, actually, if you treat 1.7 as 1 as the normalized baseline, I think we get it, these patches get it down to like 25% of that, something like that.
Okay.
So there's going to be an additional big drop here if we land those patches.
And that's DRF as well?
That's only done with DRF, yeah. We didn't look at the random sorter for this, but probably the random sorter will be a little bit worse, or much worse, because it's doing a random shuffle every time, whereas now the sorter, well, we can talk about what I did to the sorter, but I wouldn't be. I would expect that the DRF sorter is actually probably more efficient now than the random sorter.
Nice.
Mainly because it doesn't have to, like, it stays sorted most of the time, whereas the random one has to reshuffle whenever asked.
Cool. So it's like a approximation.
What's an approximation?
You say it doesn't have to stay sorted. Does it mean that if it's the order is not 100% correct 100% of the time, it's still tolerable?
I guess let's just talk through these now for this other thing. So I have to make this a bit smaller so I can see my tabs. What do we have? The important ones are, oh, I don't have a review for the next one, but this was one that makes about a 35% reduction, which was to just add a new type here that contains resource scalar quantities. We wanted to do this for a while, but we haven't yet. I only added it in the sorter for now because it's a little bit more work to pull it up and use it in the resources wrapper and all the call sites of it. But it basically just stores a vector of string scalars. And it actually replaces the hash map of string scalar totals and allocation totals here. And it doesn't change any of the logic using these things. So all that stays the same. It just swaps the type of it. And that's the first patch. I think in my runs, it goes from like 5.5 seconds to 3.5 seconds. And then I have another patch that I haven't published yet, but that takes it to about like under 1.5 seconds.
Mm-hmm.
So I guess 1.5 seconds versus 5.5 seconds is, I don't know, 25% of a little bit less. Maybe it's around 25% of the original time from when I started working on this. And then I assume if you add Meng's changes in, it's probably going to be a little bit lower as well. I didn't include his here. But I didn't mention what the next patch is. I guess I should do that. The next patch is, what's the best way to talk about this?
Just show the calculate share function.
When you tell the DRF sorter that there's been an allocation here, it goes and it updates that node. So it finds the node in the tree, it updates it, and then it walks up to the parent, to the root of the tree, updating all the parents. And then we say, okay, the tree is dirty, it's not sorted anymore, which means we're going to resort it next time someone asks for the sorting order. What I did was so I basically took out this dirty flag setting here. And in order to do that, as we walk up the tree, we shift the nodes, left or right until they're in their right place, if it's not dirty to begin with. So if the tree is already sorted and we modify an allocation of a node here, we then shift it in its parent's children into its right position. And we walk up the tree and continue to do that until we've hit the root. So whenever there's an allocation, the tree stays sorted and we don't have to resort. That's what the outstanding code is that I haven't published yet. Is that making sense?
Does that always result in improvements? I imagine So if you do so allocated is, so during each allocation cycle, you would decide which framework to allocate resources to, and you will then call this, right, to tell the sorter that it's allocated. So if you,
sorry, go ahead.
no, I'm just trying to think if.
So it's not always beneficial, and it wasn't beneficial in the benchmark that I ran this on originally. And that's because for the framework sorters, we currently update their pool of resources every time the role gets allocated resources. So I had to change that as well. And once you change that, what an allocation cycle looks like is sort, something got allocated, sort, something got allocated, and so on.
Right.
And so each time you call sort, that's what is expensive in this code here, is you don't know that it's pretty much already sorted. There's just like couple things that need to shift a little bit. And so we resort the whole thing. And then it ends up dominating the numbers as we saw in the flame graph here.
Yeah, I think you're right. Yeah, so it is one sort per allocated call. So there's
not necessarily, but pretty much. Yeah. It tends to be like sort and allocated. That tends to be the two calls that happen over and over again in an allocation cycle.
Right. Oh, yeah. Then sounds like it should be an improvement.
Mm-hmm.
Cool.
We'd have to change the way that we do DRF of the frameworks in a role. We have to make the resource pool for that, the whole cluster, which is consistent for what we're doing with the hierarchy in the DRF sorter. So we might as well make it consistent, but that may change behavior slightly if the dimension of the role allocation is different than the whole cluster size. Like if the resource ratios aren't the same ratios, then the sorting might be a little bit different.
And that's done in yet another patch.
Yeah, I mean, I haven't published those changes at all, but they'd probably be in different patches, yeah.
Cool. Yeah, that'll be interesting to look.
But yeah, I think that'll make this, at least this last case, it'll drop the first two cases a lot as well, but it'll make this last case a lot better.
I was wondering, in the current, when you say shift a bit, what are the data structure you're using to store the sorted allocation?
It's a vector.
Oh, just a simple vector. I see. Okay.
It's
I was also wondering, probably we can look at how, what is distance that's being shipped on average.
Yeah, the reason the expectation is that it's not going to be, most cases, especially in a steady state cluster, are going to be that the node doesn't shift a lot.
Or, yeah.
Even if it does, it's a cheaper operation than sorting the tree.
Yeah, I'm thinking about if we use order set, like balance tree. I'm not sure if this will be much way beneficial, but yeah, if it's only sorted shifts by say 1 or 2 positions, then definitely using vector is easier and faster.
Yeah, it's also a vector of pointers, which means it's pretty compact and probably fits in cache pretty easily.
Yeah. So in the sorter, do we? Oh, sorry.
Go ahead.
In the sorter, do we always get the like max dominant share, or we need to get the full order for the allocation, right? Okay, yeah, I remember. Okay.
Right now it is to return the vector. I think eventually after we done the refactoring, we can just, like, it doesn't return a whole vector. It's we only need to inform the allocator about who is the next.
Yeah, that's actually the next thing that shows up is the cost.
Yeah,
the cost of sending that whole list every time.
Yeah, so, yeah. I think in some of like, for example, in the kernel, this is what they do. Like, keep a repository of all the nodes and always return like who is the next, pick next task, something like that.
Well, if it's just next, maybe we can just have a priority queue, like a heap. We don't even need a like balance tree. Yep. Like, we need a tree unless we want the whole order.
Yep.
So yeah, those are the there's some other patches as well. I don't know if they're going to be interesting to talk about right now, but they're just some more minor things, just avoiding some vector resizing and avoiding some hash map lookups when you're calculating weights and things like that. And we need different benchmarks if we want to show the weight lookup improvement. Right now, we don't use the benchmark I've been running is like one roll and many frameworks in a roll. So it's a specific setup that we've been looking at, including all this stuff is that same benchmark, one roll and lots of frameworks in that roll. So we should probably evaluate the other cases, like one framework per roll. But yeah, we're making lots of improvements here. It's going to look a lot better. And we'll definitely blog about it in the 1.8 release.
Yeah. Yeah, this looks super exciting.
I'll write these down after. I'll send some notes out after to write this down. There's also been, maybe Meng, you want to talk about this one? There's been an allocator benchmarking structure that's been added recently.
Yes. Maybe I can show stuff. Okay, I think I can just talk over it. Or okay, maybe let me find the patch and share the screen. Choose a base class. Okay. All right, let me share my screen. You guys see my screen?
Yep.
Okay, so yeah, this is a test a base allocator benchmark harness for writing the benchmarks. Hopefully it can make writing allocator benchmarks easier. So what we did is we introduced a new base class called benchmark test base. And what it does is we'll take a bunch of parameters that you set and initialize a cluster for you. So what are the parameters? One is framework profile. You can specify the name, rows, number of instances, resources, etc. And the agent profile. So name, again, instances, resources, and used resources. So the base class will take in all these parameters and set up the cluster for you. It will initialize the allocator based on the parameters. You can specify different sorters, things like that, and it will stop the watch at the agents. So basically abstract all the common things that previously existed in the individual allocator benchmarks. Add the frameworks, do a settle. And then from that point, you can focus on what's happening when all the clusters are set up. So maybe let me show. So this is the first benchmark appeal edit that utilizes the base class. So what it does is it tries to evaluate. So it launches a number of non-homogeneous frameworks and try to calculate what's the number of tasks launched within a bounded time frame. So in the beginning, pause clock and initialize a benchmark config. You create the agent profile, and you create a bunch of framework profiles. Here, for example, we picked like 4 marathon instances. Like marathon is in the sense that it has a small task profile and launch a large number of tasks, etc. Jenkins, Spark Dispatcher. And then, so all these are pushed into the benchmark config and pass that config into the cluster. So the config will have a bunch of default values. Here we are using a DRF sorter with like 1 second allocation interval, things like that. Another thing is while we initialize the cluster, we pause the allocation. So from this point on, it's the cluster is in a pristine state. So that's some improvement over previous benchmark. While you're adding frameworks and agents, there might be event-driven allocations which might pollute the final result. So here, once you start allocation, it's a pristine state. And then it's all about like traversing the, so for each iteration, we advance the clock, and you will get a bunch of offer callbacks, which is put into the offer queue. And then you can decide what to do with this offer. Here, I think it's about, so for each framework, getting an offer and then launch a bunch of tasks given several constraints. For example, each framework has a max tasks per offer. So it will try to launch as many tasks as possible. Like the launch here is really do not decline the resources. So after we exhausted the offer, we decline the remaining resources. And then at the end, we print out a bunch of statistics. So yeah, so this space is really about initialize a cluster for you. There are more future works, especially given the test body part, where I think this part can also be automated. So hopefully in the future, while you are creating the framework profile, will allow you to specify how the framework will be treating those offers. So all you need to do is think about, okay, I'm giving an offer and what I'm going to do with this offer. So so basically this part of the test body will be automated as well. So in the future, hopefully writing a benchmark is just about populating all the fields in the benchmark config. And once that is done, you can just kick starting the allocation, and then you will get the statistics you want. Yeah, I think that's pretty much it. So yeah, right now the base is there, and there's only one benchmark that's currently using the base. I'm planning to like maybe slowly migrating other benchmarks that try to benefit this from this base. and also add some other benchmarks. In particular, one currently in my mind is quota-related benchmarks. Yeah.
Can you show us the statistics that get printed?
So right now, the task, the base doesn't have any built-in statistics. So all these are within the test body. So each test individual will print out, like collect and print out those statistics. I do have a plan to add metrics, especially the allocation latency, to the test base, so that you don't need to, so that at the end you can just query the metric snapshot and it will print out at least the allocation latency, number of allocations, etc. But right now we can't do that due to the fact that the metric right now depends on the clock, the lib process clock, and we can't do that because in the test we are manually controlling the clock and it will mess up with the metrics. So once we decouple the metrics from the lib process clock, instead use stopwatch, we will have built-in metrics in the allocator test base. But things like cluster capacity, cluster allocation, and all these things, the individual tester still needs to, collect and report itself.
Yeah, I was curious what they, like, do you have an example output of this benchmark?
I think it's here.
So I guess at the bottom it's showing that the target allocation was not reached in 30 seconds.
Yeah. Yep.
Okay.
So yeah, so the test is what the test does is each framework has a target number of task instances, and then in the end, like after 30 seconds timeout, it will print out what are the CPUs and memories being allocated versus. So this is actual allocation and this is target allocation, which is aggregate number of target task instances all the frameworks wants to launch. Yeah, I think that's all. Any questions? Okay, I think that's all.
All right. Thanks, Meg. Let me grab the agenda again. All right. The next thing was, I think I might have a ticket for this. I tried to capture all of them in this ticket here, but when I was auditing the code path on the master side, if you look at the benchmarks that Meng's been talking about, none of them benchmark the actual master side of sending those offers out to frameworks. We don't have a benchmark for that right now. So I don't know how much these changes actually improve things, but I did an audit of the code paths there, and there were a lot of low-hanging, expensive things that we were doing. So I think at this point I cleaned up most of them, and there's still some more work that could be done, but I think even just now you should see a large improvement. One of these was actually a regression in 1.7, which was that when framework metrics were introduced, the way that metrics were being incremented was by evolving the message to V1 and then devolving it to a non-V1 call, which is copying it twice for every outgoing message to schedulers, V1 schedulers. Actually, to do I don't remember if that's for every scheduler or just V0 scheduler. Yeah, I think it's to every scheduler.
I wonder
So
why
that,
we are doing that. Why we evolve and devolve.
well, the patch that I had was to instead have a specific overloads for increment event that knows how to handle all of the old style messages here. Because previously there was only an increment event for one type here, which means you have to convert it
Okay.
into this type. And it's the entire type. It takes the whole message, not just the event type. So this just adds overloads to increment the right thing. So that we don't have to copy it at all. We just pass it through. And then a lot of the other stuff was just like making sure vectors have the right capacity where we can, and avoiding looking up things multiple times in maps. And then the main benefit, I think, from these patches is just eliminating copies of protobufs. The one I just showed was two extra copies of every outgoing message. There's this patch, which was reducing copying of the resources that we're sending out. There was reducing copying in the evolve helpers by using moves instead of copy from. And there was yet another copy of the offers because the way that the repeated fields wrapper was implemented for evolve was it actually took in the argument by copy by accident, I think. So there was another copy there. And at this point, it's pretty, it doesn't have a ton of unnecessary stuff going on. I still haven't had a chance to benchmark evolve, but I suspect that there's room to improve that because the way it works right now is it deserializes and serializes the offers. So when it gets down to evolving an individual offer itself, it goes through this path, which is going to deserialize the V0 offer and then serialize it back as a V1 offer. You'll notice that some of the overloads here actually don't do that. They have logic to just copy it over. And the note here says, like, since this one's common, we wanted to speed up performance, which makes me think that maybe they benchmarked this, but I think it should obviously be faster to not deserialize and then serialize back in this particular case where you're copying just one string. There's also room in this code here to like take R value references and move things, but it's going to be quite a bit of work. So until we have a benchmark, I probably wouldn't look into that more. So we still need a benchmark for the master side of sending offers out to make sure we can do that as quick as possible. And there's lots of things we can still improve there. I think I tried to write them down in this ticket. So there's the serializing costs that I just talked about, and then there's also, we could use some parallelism to speed up sending out the offers. That's pretty much it for that one. I don't know, again, how much it's going to improve things, but I suspect that it's going to be pretty significant given what we saw when we did copy elimination for the master failover benchmarks. Probably in 1.8, I will try to get a benchmark so that we can show this improvement in the release. But I'll probably do that closer to 1.8 unless someone wants to help out with that. Any questions about that?
Nope.
All right.
Yep.
The second last thing was, I'm almost done with the 1.7 performance blog post. I'm just waiting on some benchmarking data from Benno and Alex, and then by the time that they're done, we'll probably be able to show some better, master branch numbers for this stuff. And then I think that'll be it, and we'll be able to publish it. And then, yeah, Ian, you wanted to talk about the scheduler call ingestion performance.
Well, really, this just occurred to me while we were talking about possible things to discuss, and I'm not fully aware of the current state of things, and I was asking whether people here are aware of them. So I think in general, this has been a pain point. I don't have specific numbers. So I think that's overall. I just had a abstract idea that I need to get this improved. So not necessarily I have specific things that I will have cycles to do or expect that we do next. It's just something on my mind.
Okay. Yeah, I think I seem to remember something from Ilya. How do I don't know if he reported it or. Yeah, I'm not sure how to search for this ticket, but
Right, so scheduler V1 improvement certainly includes
yeah, I'll have to do some looking around after this to figure out where that was left.
Yeah, it's okay. I think maybe I will do some research and probably be better prepared for the next session.
Okay. Just doing a quick search in my terminal for all the benchmark tests. Yeah, okay, that's what I suspected. There is a scheduler reconcile tasks benchmark test. I thought this was what Ilya was using. So this will.
Right, yeah. I remember in one of the previous performance meetings, he shared the numbers using this benchmark probably.
Yeah. So this benchmark is basically just like, don't even set up a cluster with agents and stuff. Just send a big message to the master. And where does it time it? Okay, so it just times how long the send takes for things to get settled. Yeah, so we could use this to just take a quick look, run perf on it. I don't think he ever, back then, I don't think we were asking folks to provide perf stack traces, but it's probably as simple as just running this and getting some perf data and kind of sharing it. And if we see any obvious problems there, we can take care of them.
Cool. Yeah, I think we can probably do that. Yeah.
Yeah. Yeah.
Yeah, but obviously, I think that this is making me pretty optimistic, because previously when I saw the random sorter, I was actually gonna try to switch to that and see what performance should look like. But it looks like, because ultimately I think in our environments, the fact that one framework is just starting out with nothing, and the other framework being 80% of its way to fully launch, doesn't necessarily suggest any kind of priority to
Right.
us. So I was gonna see how much a random sorter is gonna help, but seems like
Well,
the
in that
level
case, in that case, you might want to actually use the random sorter, since it sounds like those two frameworks are equal in your scenario. It's just we haven't. There's room to optimize the random sorter as well, if you do go down that route. It's just going to mean that those two frameworks are equal, instead of the one with 0 resources getting a lot more than the one with 80.
Yeah. Semantically, I think that matches the expectation on random sorter. But then you were saying that actually the performance for DRF could be actually equivalent.
I suspect that they're probably equivalent today, or the random sorter is probably a little bit faster at sorting, but after these patches, it's going to be worse. It's going to be slow. The random sorter is going to be slower, and unless we do the optimization to be able to like iterate without having to sort the whole thing, it's going to be hard. Like, that's the main optimization we'd have to do, is let the caller kind of iterate in some way, which basically means, if you only needed the first 2 results, you just did 2 random samples rather than doing a random sampling of the whole data set and sorting it. So it's definitely optimizable as well. Most people are using the DRF sorter, so.
Yeah, you're right, but many things to play with.
Yep.
Cool. Yeah, sounds very good.
All right. Glad to hear it. I think that's it, unless anyone else has anything they want to talk about. Nope. All right.
Yep. All right.
Thanks, everyone. I'll send out some notes after this.
Thank you,
Thank
Ben.
you very much. Yeah.
Yep.
Take care.
Thanks, Ben, man.